With just few core ideas, subtrees, merging, and rerouting, we can solve surprisingly complex problems that looks intimidating at first glance. So what kind of problems are usually used in DP trees? Some problems only care about local subtrees like computing subtree sizes or sums. Others are global like finding the tree's diameter or the sum of distances from every node. Thanks to the structure of trees, the same DP pattern unlocks all of these. If we pick any node and declare it as root, everything under it becomes a subtree. And because this is true for every node, we can compute a DP state for each of those subtrees. One per node. DFS naturally visits the tree in a bottom-up fashion. It starts deep in the leaves and climbs back to the roots, which perfectly fits with combining child DP values into parent DP values. Most DP problems follow a simple pattern. Take answers from all the children nodes and merge them to compute the parent's answer. The merging logic changes based on the problem, but the pattern remains the same. The heights of a subtree is similar. Leaves have 0 height. Every other node takes the maximum height among its children and adds 1. Again, we combine from bottom to top and we're done. Now what about something more global, like the diameter of the tree, the longest path between the two nodes? The path might not follow through the root, so we need to think more carefully. This might be a clever insight. At each node, we track two values, the best downward path into its subtree, and the best diameter entirely within the subtree. By combining children's height, we can find the best possible path that passes through a node. And again, pure merging logic. Sometimes we need answers not just for one root, but for all possible roots. Instead of recomputing DP from scratch for each, we can reroute the tree, transforming answers in linear time using previously computed values. To achieve this, we use two DFS passes. The first computes subtree information from bottom up. Second pushes information from parent to child, adjusting values as if the child were the new root. With these two passes, we compute answers for all node in big O of n time. So the DP pattern looks like root the tree, run a bottom-up DFS, optionally run a second DFS to reroute. And remember that DP states often store multiple values. Once you realize this structure, many tree problems become approachable.